Okay, today we're going to look at the domain of radical functions, and basically, sometimes this is really ridiculously easy. If you're looking at an nth root where the index is odd, so if you're looking at a third root or a fifth root, etc., the domain is the set of all real numbers. Remember, domain is your x values. It's what x values can we use in the function. So with an odd index, like a cube root, you can do the cube root of negative numbers, you can do the cube root of positive numbers, so your domain is all real numbers. There's no limitations. However, if n is even, if we're trying to do a square root or a fourth root or a sixth root, etc., can we do the square root of negative 16? No, we'd get imaginary numbers. So the domain is going to be the set of all non-negative real numbers, because you can't put a negative number under the radical. To find the domain, set the part under the radical greater than or equal to 0, and then solve. So first, I want you to look at these three examples and look at, do any of these have an odd index? C has an odd index, the fifth root of x. With an odd index, your domain is all real numbers. You can put anything into that function. So when you're doing these problems and it asks you for the domain of the function, look at the index. If it's odd, you can write all real numbers. Now let's go backwards and look at B. B has an even index. So we take the stuff under the radical, which in this case is just x, and put it greater than or equal to 0. Then we would need to solve that inequality. Guess what? That one is done. In A, what's the index on this radical?
2.
A 2. This is a square root. That's even. So put the stuff under the radical, x plus 7, greater than or equal to 0. Now we need to solve this inequality. That means get the x by itself. How would we get the x by itself? Subtract 7. So x is greater than or equal to negative 7. As long as you pick an x value that is negative 7 or larger, you can do this function. I think you've got a little bit of extra space either on that slide or maybe on a slide above that where you can do a little bit of extra work. I added a blank slide to the presentation so that we could look at a function like this. What if the function is the fourth root of 10 minus 2x? Find the domain. It's an even index, it's an even root, so we do need to set it greater than or equal to 0. Put the stuff under the radical, greater than or equal to 0. To solve that, what should we do first? Subtract 10 on both sides. That will leave us with negative 2x is greater than or equal to negative 10. Now what? Divide by negative 2. On the left side, we have x. On the right side, we have positive 5. Anyone have any comments about the sign? Flip the sign. Because we divided by a negative 2, that sign has to flip. So your domain would be x is less than or equal to 5. As long as you pick an x value that is 5 or smaller, you can do the fourth root of 10 minus 2x. If you choose an x value that is bigger than 5, like 6, 7, 8, then you would end up with negative numbers under that radical.